Hey everyone, we're live, and this is the final episode of the series. I built at 4 a.m. Modularity, simply put. And as our guest here, I couldn't ask for anyone better than our own technical coordinator, Milton. And I think this chat is gonna be really nice because he's gonna show us in this conversation how Cartesi is actually very modular, right? We're gonna talk about some awesome integrations that we did with Espresso, Avail, and the potential for many other integrations that Cartesi can leverage. So, hi Milton, how are you?
Hey, hello. Nice to be here. Good to be able to talk about some exciting stuff that's been going around. So thanks for that.
Yeah, thank you so much for coming. First thing I actually want to know, get your a little bit, pick your brain here, is how did this idea to integrate Cartesi with this DA services data availability solutions come about, right? Because it's something that we always talk about how an execution layer has a great synergy with data availability layers. What motivated Cartesi to explore these integrations with sequencers, with DAs, and everything?
Yeah, so I guess the first thing that we could talk about is that like Cartesi applications, they are really prone to wanting data, right? This is an old discussion within Cartesi over the years. Uh, Cartesi is focused on app chains, right? The rollups that are a single application inside a rollup. And so we are able to provide a really an uncomparable execution environment with a lot of computational power, which basically gives applications like a Linux machine in which they can run any mainstream software. And so it's just natural that apps that have a lot of computational power on their hands, they will want to process more data, right? Because if you can do a lot of stuff, you can have databases, you can process like streams of data, but then where does that data come from, right? The vanilla Cartesi rollup deployments that we have, they are pretty much constrained by the data capabilities of what the base layer can provide. So basically, anything that you can put inside your rollup is what goes through the base layer. And if the base layer only accepts very limited data, then that's how much data your application will have to process. And it often is the case. We saw this in lots of people from the community in events, that people just go, "Whoa, I can't have like all these megabytes. It's just 1 megabyte. I just want to put 1 megabyte there," and it's not there. It's just something that wasn't available. So integrating with DAs is something that we've even thought about doing our own in the beginning, and but now one thing that happened in the last year or two is the rise of this modular world mindset, right? So in Web3 in general, this has been becoming stronger and stronger. That projects have over the years focused on a certain area of expertise. So this is no different for our case. So Cartesi has focused on like provide the best execution environment that can be, and also now also coupled with the best product proof system that we could imagine. So we've been focusing on that, and it's just better for the Web3 community in general. I think that this modular mindset comes to everybody, and we foster like meaningful collaborations between the projects. Each project has its own expertise, as I said, and then we can have as ourselves, we have our expertise that I just said, but then other projects can focus on scaling data. They can focus on providing low latency or like authentication capabilities or decentralized sequencing and many other things that are important to get the whole proposition of Web3 to scale to its full potential, right? So
Yeah,
there's so many progress going on in so many areas, and we just figured that if we can integrate with other projects like Espresso and Avail that you mentioned, not only we can like offer like technically speaking more features and more a better environment for the applications, But the exchange of ideas with these other projects is also crucial. This is what has been motivating us to do this push, and which I think is the best aspect of the modular landscape, is that the projects are actually talking to each other and trying to get the best of everybody together for a better Web3 for everybody.
I think you touched a point there that is very nice, which is like the interaction between the protocols and the people who are building these protocols. Because I remember even before, at least before I heard of the modularity speech, on Cartesi, we were already talking about how the data availability helps with the execution layer. We even had a very nice blog post on Grok in Cartesi Rollups that showed the cone of innovation, right?
Yeah.
And the potential that it was unlocked. But I think as we start to discuss many more possibilities of applications that comes also from the other side, from this exchange, becomes real, right? Is there anything specifically that you've seen coming from any of these other sides that you thought it was really interesting, or something that you found unlocked that called your attention?
Yeah, if I want to say one thing, it's I guess one of the biggest challenges, and what everybody in the industry has been talking for the last year or so, is that we need to get real applications that really foster mainstream adoption. And it's been a little frustrating, I guess, for everybody to try to figure it out by themselves and try to build find the use cases and design your solution around that use case, and then see that use case is, I mean, we've been trying this, and it's so many intelligent and knowledgeable people in the industry. It's just so much better if we talk to each other about what we have and the technology that we provide, because sometimes the simple movement of showing to each other what's possible that you didn't even imagine was possible before. So, okay, you can just run this algorithm here inside the Cartesi machine, and it works. And with that, you could actually unplug something else. But for that, we need low latency, or we need more data, or something like that. So when you bring these people together, these use cases can be explored and validated, and you can get feedback. And also in the level of the design of each one to make these happen. But I guess just exploring use cases together is what I think are best.
This is awesome. Can you talking about like this process of implementation of ideas happening? Can you walk us through the high-level architecture, how it was designed, how the idea came about to plug and play these components together, like with the different DA layers, like Espresso, like Avail, and how this whole process happens from this technical perspective?
Okay, so I'll go a little bit into detail, try to not go too much. So the regular Cartesi Rollups that we've been offering so far, they have a very simple way of processing transactions. So basically, any payload that you send to a specific smart contract, which is the input box contract, you give the application's address as a parameter, and that transaction is going to be processed by the app chain. So it's like forced inputs in a way. It's like all the inputs that we have in a vanilla Cartesi Rollups are like forced inputs. You go to the base layer, you send it there, and it's processed. So under technical perspective, what we did is that in the node, first of all, in the node that with the Cartesi node, which is running the application, the rollup application, we isolated a component which we call the input reader, which is the one that actually does what you could call the derivation pipeline, right? So it's the one that reads data from the app chain source of data and extracts the transactions from it, and then is able to process that. So what we did now is basically you're able to swap that to another alternative implementation, which can read data and derive data transactions in different ways. So for instance, our Espresso reader can now read blocks from the Espresso network and derive transactions from there. And then it's not only transactions are encoded in the Espresso block itself, but also from the Ethereum block that's associated with that. So that's basically, in a nutshell, the idea that we are able to hopefully in ways that are progressively easier for the developer and user, but just choose like a different reader, and then you will read from this alternative DA and sequencer.
But at the same time, you have to keep this communication happening together with the layer 1 implementation, right?
That's a choice that we made. So Cartesi Rollups right now, they have an interesting capability in which some other systems, you can only bridge assets inside your L2, right? So you have an L1. All transactions happen on the L2, which we could call an L2 transaction. So if you have like a regular OP stack, a rollup or whatever, you will go to that a gateway to that rollup, and you just send transactions there. And if you needed any interaction with the base layer, with the L1, you would have some bridging mechanism basically for assets. Even if some of these systems deep down inside, they have a general purpose messaging system, but generally users only do that. In Cartesi Rollups, it's very common that you actually have this more general L1 to L2 messaging, which is the way that we see it, available for people to use. So this is useful not only for depositing assets, but also for relaying some other information, such as you send some transaction to the base layer, it checks some authentication contract. It could be like using some external protocol, like Privado ID or something like that. And then it sends a message to the rollup saying, okay, this message sender is authorized, something like that, or is authenticated, right? So in order to keep that functionality, which many of our applications already use, and especially to keep deposits working as they already do, and make it easier for applications to just choose, okay, I'm working this way, so I'm sending deposits and other regular transactions on this vanilla way, but now I want to send these other regular transactions on this other alternative DA layer so that I can send like larger chunks of data. It's cheaper, it's faster, or anything like that. But we wanted to retain the capability of depositing assets the way you currently do, and relay information the way we currently do. So in our integrations so far, we have kept, and some systems like Espresso help with that, because Espresso are tightly coupled with a base layer, with the Ethereum base layer, and it's easy for us to keep reading the base layer because there's a clear synchronization point between the Espresso block and a corresponding Ethereum block. So we take advantage of that and allow applications to still benefit from those interactions with the base layer, while keeping like a regular L2 transactions cheap and full of data.
Getting the best of both worlds, and at the same time, it's good for developers because they are working with what they already know how to use and how to deal with. It's not completely learning something completely new.
And not only that, there's been discussion here inside Cartesi that it's been proven really useful for applications. The feedback that we get from users and developers is that these features that you could just like send a transaction, you could check a smart contract, any smart contract, you can check if you own an NFT, you can do whatever on the base layer, and you can relay that information to the rollup. This is extremely useful, and we've seen applications use this extensively. And so we really are wary of not taking that away, right? If we're giving cheap data, we don't want to take away this functionality that people are finding useful.
Yeah, the quality of life that comes from it. I have a hard time remembering an application that does not use this whole portal system and this integration, which is really nice because it makes our life really easier. And from another side, there must have been things that were extremely hard to do in this whole process, in this whole integration. What challenges did you find when integrating with different protocols? What were the complex things that you have to tackle, and how these conversations went on about?
Challenges in terms of actually implementing the solution, you mean?
Yeah, technical challenges you saw while designing the solution, while figuring out how pieces should come together, or even technical challenges that you see people have when they use these tools. Anything goes.
Yeah. So from our point of view, I guess biggest challenge for any integration is, first of all, assessing and evaluating the viability of doing it, because to actually do the integration, you can't just read from a different source. You need to evaluate if it's possible to potentially do that in a safe way, which means basically integrating it with our fraud proof. So basically, you can only integrate with a external DA if you have a way to prove the data availability on the app chain's base layer. So you need some sort of support from that protocol. So it's common that these protocols do some sort of commitment on chain, and you need some mechanism to be able to verify whatever data you use in your rollup, that it's compatible, it's compatible with whatever commitment is there, and there's a way to prove that. So evaluating if that's possible or not is something that is important in our perspective when starting to integrate, and evaluating if that's possible. And in a way, it's also important from the user's perspective. If you were to demand or see interest in a certain project, it could we are doing these integrations because we see demand from community and importance of these other protocols in the industry. If users were to choose between one of these, they would also look at and see if the project, the trust assumptions that it does, or the technology that it uses is something that he believes in, right? So yeah. I think in that part, it could be a challenge for the user as well, because it is different using a DA layer than not using it, because you have to take into consideration trust assumptions of that DA layer, right?
It's something that the developer, while he's designing his solution, he has to think about if this will fit the scope that he imagined before coding anything, right? Can you say it's a direct impact on security of the rollup itself, or it's more just the solution, the way that the developer adds it to their project?
I'd say I think, frankly speaking, there is an impact on the security, because the trust assumptions are different. That's undeniable. So anytime and if you talk to certain people in the industry, you know that, right? Certain people only, if it's not everything on the base layer, all the data is on the base layer, I don't even call it a rollup, I call it a Palladium, I call it something else. But so it is true that the trust assumptions are different. Still, many of these projects, like Espresso and Avail, they offer very robust security guarantees. So sometimes even comparable to the base layer, some would say. And so it's basically just, am I okay trusting this protocol, that the security guarantees that they are putting forward are almost as good enough as the security guarantees of the base layer that I'm using or whatever. So it's, in that respect, maybe it doesn't affect decisively the security of the rollup, because it's really good enough for the kind of application that you have or the trust assumptions that you have. So it's yes and no. Of course, it has a difference. It's something to be considered, but it's something that could well satisfy many application demands, right?
And it's something that you could say that the Cartesi part at least operates the same way, under the same trust assumptions, right? You're just plugging the trust assumptions of that sequencer or that DA as well?
Basically, yeah. The only difference from a Cartesi point of view is that if there is some dispute, right? So if you have like different validator nodes and one of them is misbehaving, so one of them is trying to steal funds or do something like that. At some point, you will need to say, okay, but did the user actually send this transaction asking to withdraw assets or anything? You have to prove that this input really came in. So at this point, we need to ask the DA layer, okay, is this piece of data part of the data that you committed on chain? And this is the part where we trust the protocol that the commitment on chain was really the smart contract where this commitment is stored really does a correct job evaluating the signatures of all operators in that network. And you can trust that, so that this transaction did happen on that network, and we can go forward. So this part is where we forward trust to the protocol, to the external protocol, right?
Right. It's funny because you mentioned that all the trust assumptions, it kind of feels at some point that blockchain as a whole is still in this, Web3 as a whole is still in this somewhat experimental state, where at the end of the day, you have to accept some things to use. It's not completely easy to understand everything that is happening in every protocol, so you can know how much you can trust each of your applications, right? I always find myself in a pickle trying to understand, like, okay, what I can really trust from this solution and what I can't. I'm always curious to know how other people go on about this and they think. Do you have any thoughts? Because as a technical guy, you can actually read the paper and understand the implementation much better, right?
Yeah, but you mean for people in general?
Yeah.
How can they reason about it? Yeah, I think the main thing to do, in my opinion, is to have some sort of algorithm, rule of thumb that you use to just evaluate how serious a project is, right? So you could, of course, if you have the technical capability, try to read a paper, the explanation. But there are some cues that you could use as well to say, okay, can I trust this? Okay, is this project like well regarded in the Web3 space? Do they actually get invited and participate in like protocol discussions? Are they always present on DevCons? They give presentations there. They participate in the work groups. This is something that you don't need to understand the technicalities of things, but just to see that they are actively participating and proposing things that are understood by other people that you trust, ultimately by like the main people in the Web3 space, or even Vitalik, whatever. So you see these people are actively always engaging in these deep discussions. Then it's a good sign that the project is serious, that the people are trying to do something that makes sense, which doesn't rule out the possibility that there are flaws or bugs in the implementation, right? But at least it's a good sign that the project is sound and it's going to be around for a while. Another good sign is how long have they been like on mainnet or around, right? So if they've been there for a while and nothing has happened very seriously, then that's also a good indication that this is not just some wild project that came out of the blue promising lots of good stuff, but nobody ever used it, and you're the first one. So that's a bit risky.
Standing the test of time.
Yeah.
You mentioned DevCon in this answer, and this just brings me something that I wanted to talk to you about. Mm-hmm. There was this huge discussion on DevCon regarding interoperability, right? Mm-hmm. And this is something Espresso talks about a lot also. Mm-hmm. Is there a way to think of sequencers in this solution helping in interoperability between rollups? How do you see that? Is this something feasible? Does this bring more challenges to implementations and integrations and app creations?
Yeah. So composability is a huge subject and a big challenge. As you said, was one of the hottest topics at this DevCon last month. You have really a lot of people, a lot of projects devoting their attention to it. It's a necessary challenge because with the rollup-centric roadmap that we have, especially with app chains, that is our focus here. At least for assets, composability is key feature to avoid like fragmentation and having a really, really bad user experience as these rollups multiply, right? There are many kinds of composability, right? Asynchronous, synchronous, composability between rollups that share some same technology. So they're calling now rollup clusters or something, or composability between different clusters. Also, there are composability which are more general purpose, like message passing between different rollups, and then composabilities which are just like faster asset transfers via some atomic transaction scheme, something like that. So in the context of Espresso and some others, having a global ordering of transactions for all rollups at the same time is it's a key aspect to getting this kind of interaction between them. Otherwise, if they're like independently sequenced, as they are now, right? You have the arbitrum sequencer and the superchain sequencer or whatever. It's very hard to infer in which order you should process transactions that are trying to bridge the gap between them. So this is one of the major propositions that Espresso has. There are other people talking about base sequencing and other solutions that you could use to have like this hub where the transactions are globally ordered in some way. But in general, like people are still figuring out standards, protocols to try to get to a point in which we could like that. Some think it's too much of a stretch, but I mean the final ideal goal would be to have instantaneous general purpose message passing between rollups. But in my opinion, we could settle for a lot less, especially asset transfers are what I would personally see as the game changer for this. If you can bridge assets around, the rest is not so drastically important in my opinion.
Yeah, the generic imputation of information is not as critical as the asset handling.
Right? Very cool. But I think we can do a lot without it already, and it imposes a lot more challenges. So, yeah.
I mean, regarding these challenges, I don't know. I might be completely wrong, but just thinking the way these prototypes of integrations, right, from Espresso, from Avail were created, having the assets being transactioned through the layer one, through the portals, contracts. This is kind of opposite to what Espresso desires to do in this composability speech, right? Because then we would have to use their sequencer. I'm not sure.
No, it's complementary, right? So first, assuming that assets are somewhere, let's say assets are on Ethereum mainnet, you need to deposit them on some rollup at some point. So either you bridge them to some, you need to, if you want to, let's say Espresso has a nice composability or asset transfer system, a protocol in place, and everybody who's on Espresso is able to tap into that. So somebody has to put assets in one of these rollups to begin with. And this is what we currently offer. What we don't currently have is this protocol that allows you from one rollup to jump to the other rollup, but you will need to put it inside first at some point. And of course, I mean, I think one of the goals is that once this protocol is mature, maybe like ramp on centralized exchanges and things already go directly to the rollup. They already have a presence there or whatever. Then maybe it doesn't go through the main layer. But I would say for the foreseeable future, the assets are on mainnet and they're deposited on one of these rollups. And then as time goes by, we'll get better and better at moving these assets around without having to go back to mainnet every time we want to move the different rollup, right?
That's great. That's actually great to hear. One last question about these in the integrations. What future features or enhancements are in the horizon for these? Are there any specific plans?
So we have made some initial integrations that already work great. I have a number of applications using them. Our main goal, to be honest now, is to integrate these integrations with our coming fraud-proof system, which hasn't been made live yet. But the idea is that we can integrate these and make them available in this permissionless stage 2 setup that we want to provide. Other than that, I would say that the main feature that we want to provide is having the convenience of making it super easy for devs to just choose, okay, I want my rollup to be using this integration or that integration, and the rest of the application has next to zero impact on its code and how it works. So you can just choose a different DA layer which matches your trust assumptions or the scenario that you're comfortable with, and you go on with it. Other than that, I would say that not in the near future, but as these composability protocols mature, then providing some specific features to be able to bridge assets or something like that between these rollups that are under this the umbrella of some protocol like this would be the next thing to tackle.
This is great. It's great to hear. I look forward to seeing all that coming together.
It take a while.
Now, I wanted to have a quick rapid fire questions round for you, where I'll propose some questions, shut them real quick, and you give me fast answers without thinking too much. One word, one sentence, not going along a lot on each of them, right?
Right.
So, what's your favorite recent innovation in Web3?
I would say using ZK in fraud proofs. This is the recent innovation that people are not. I'm not sure how aware people are, but this is very, very interesting.
What's one misconception that people have about rollups?
Oh, I think the main one would be that I'm not sure if this is a misconception that people have nowadays, but they have had that for a long time, that you can just offload the entire layer 1 to a big layer 2 and everything is now fast. So that's not how it works. It will be crowded too. We need something like app chains to really scale. So
now another misconception, but about DA layers or sequencing layers or
that it's being solved. I don't think so. We still, it's still there. We still have to work, especially on decentralized sequencing. It's still something that's important, and people are working on it.
A long way to go. What's a must-follow resource, blog, or person to follow to stay updated on Web3?
Well, for anything Web3 and beyond, the easy answer is Vitalik, right? But for rollup stuff specifically, I would say follow the L2Beat guys. They put the notes where they should be, and it's very, very good to have a clear idea of what is and what isn't out there.
That's very true. Now, last one. One piece of advice for developers exploring blockchain right now.
It's a tough one. I would say spend quality time trying to understand the real utility that blockchain technology can bring to people, more than following any hype or going after something. Just trying to understand why is it useful, and then build on top of that.
That's actually great advice. To be honest, I would love to hear that more when I started hearing about Web3. Now, going back a little bit to our discussion, Cartesi has this ethos of open source, right? Community driven, how everyone should collaborate, put everything together. And this is beautiful when you talk about decentralization as well. I think it really gets in sync with the ecosystem as a whole. What do you think are the contributions that this ethos, this community driven development, what are the contributions that it provides, it plays in advancing these sorts of integrations, in advancing these sorts of collaborations?
So community-driven contributions, you say?
Yeah.
Yeah, so they're essential in more than one aspect, but I think the thing that most touches me is the community is the one that actually defines the demand for what needs to be built, right? So the demand for actual use cases, they come from the community. So which features applications need, which technology that different projects are building helps in that. So that drives everything. And other than that, I think one thing that we particularly in Cartesi, we improved a lot over the years is that to do the discussions in the open is something that surprisingly, it's incredible how at some points where it's almost unexpected, people will chime in, give some really, really brilliant feedback or insights, and ideas just flow better when they're in the open. This is something that we've been particularly pushing in several spaces, that people need to talk more openly about research they're doing. And this is how science has progressed always. And this is how I think we can move forward as a community, as Web3 as a whole.
I completely agree. I don't think one person alone pushes science, right? I had this discussion with a very smart mathematician. I know, won't mention his name, but it's very funny when you think about calculus, for example, when it was invented. Why Newton and Leibniz arrive at the same conclusions at the same time? It's because other people were researching and publishing about it, right? So it's when you publish that you allow other people to study and develop on top of what you're developing. Which actually creates the new and good things that we actually use. And yeah, how do you envision that all of this that we've been doing and what you've been doing, working with these other pieces of the stack around Cartesi as well, like DAs, like sequencers, external sequencers, how do you see they play a part in the broader Web3 ecosystem in the next few months, years, decades?
I think we touched on this already. It's for me, it's a given that it's essential to have like cheaper and reliable data, fast, secure sequences that are decentralized, so that we can scale Web3 apps to their full potential, right? So as I said, like we are firmly believe in the app chain perspective, and this is how we see this going forward. So we do believe, as you mentioned in the cone of innovation, things like that, the real potential of Web3 has still not been unlocked because things like these, not only these, right? It's not only DAs and sequences that will bring us there, but they are important bricks in building this construction, this castle, and bringing together in the end, not only, as I said, the technology part of it, but having people actually exchanging the ideas and possibilities that they provide, that we can get all the minds from different projects or from the community and really come up with the massive mainstream projects that we've envisioned for a long time, but we're not there yet, right?
Yeah, this is what I love about the modularity speeches. Like, work together, build together. It's really nice. It's inspirational. What about in general Web3 as a whole? Any hot topics on your mind? I know you mentioned ZK on fraud proofs. What you looking forward to?
Well, we also mentioned, like, it was very clear for me when I was at DevCon that the two main topics on Ethereum now, and I'm taking Ethereum as a important part of Web3, so I'm basing myself on that, is that composability is one thing that we already mentioned. It's like the hot topic of the moment, together with removing training wheels from L2s. So that's, I think, the hottest topic of the next year. We've been working hard on our own fraud proof. As we said, like, ZK is becoming more and more a part of all the fraud proofs out there. ZK validity proofs are evolving more and more. And it's a matter of time so that we have rollups that grow up, as some people say, and they don't need the training wheels anymore, and they're secure enough, and we get there, because we're still not there, right? We're doing things faster and cheaper, but not as secure as they were before. So we need to fix that. And besides that, there's another hot topic coming up, I think, which are some other newer magical cryptographic technologies like obfuscation, which promise some new revolutions. I'm personally not an expert in any of these, but I can feel that it's creeping up around, that ZK is just the beginning. There will be something way, way more complex and magical than that.
Yeah, it's crazy how you see, like, ZK, FAG, everything come together on obfuscation. I remember talking to Augusto, who's one of Cartesi's founders as well, and he was actually so excited about everything coming together. It's like, this is so cool, this is so amazing.
But it's still a long way. Like, I remember we talked to obfuscation guy there and say, oh, can we already do? No, we can only, like, do a very, very simple thing, almost like quantum computing.
Yeah. But it's something to look forward for.
Yeah, it is. And it has this promise of, among other things, like privacy preserving logic, like, just, you don't know what you run, but you know that it executed correctly. You can store some private keys inside, no problem.
For me, it's the definition of magic. It's not something that does not make sense. It's just something that I don't understand yet. Anyway, Milton, this was amazing. Thank you so much for coming and talking about all that we've been cooking. It was really nice being part of the process, seeing everything happen, and now having the opportunity to talk to you about it. Feels like it's like probably the 10th time I call you to talk about this time being recorded, and I still have so many questions on all of it.
Yeah, things are always evolving, and exciting news are always coming up.
Well, thank you so much, man. And this was the last episode of the series. We're coming back with another series on January. I'm sure I will be calling you on them as well, so you can give us more insights and allow us to pick your brain one more time.
All right.
Thank you so much. Bye-bye, everyone.